Alright everyone, welcome to Tutor Terrific. This is part 3 of our 3-part series on deriving the sum and difference formulas. Today we are going to specifically derive the formulas for tangent of the sum of two angles and the tangent of the difference between two angles. These formulas, again, with the other 2 parts of this series, are amazing because they are the foundation for so much of analytic trigonometry. A bunch of other formulas can be derived from these guys. Now, here are the formulas we're going to work on today. We're going to start by deriving tangent of u plus v, which is the tangent of u, plus the tangent of v over 1 minus the product of tangent u and tangent v. Then we're going to derive, based on this result, tangent u minus v, which is equal to tangent u minus tangent v over 1 plus the product of tangent u, tangent v. As you can see, the signs have just flip-flopped. So here's how we're going to begin. Knowing that tangent is defined as sine over cosine with the quotient identity, I'm going to write tangent of u plus v as the sine of u plus v over the cosine of u plus v. This is the quotient identity, and this is completely valid. Next, I'm going to take these two terms, and I'm going to expand them using the sum and difference formulas I derived in part 1 and part 2 of this 3-part series. So this is equal to sine u cosine v plus cosine u sine v. That's what's going on top. On bottom, I have cosine u cosine v minus sine u sine v. Okay, and these are those 2 formulas written out. Now, the only unintuitive part in this process is what I'm going to do right now. I'm going to divide both the numerator and denominator by the following product: cosine u, cosine v. So both the numerator and denominator will themselves become fractions with cosine u, cosine v as their denominators. So what does that look like? Well, it looks ugly, but we're going to write it anyway. Sine u cosine v plus cosine u sine v all over cosine u cosine v. Now, the denominator is cosine u cosine v minus sine u sine v all over cosine u cosine v. Oh my gosh, this is getting out of hand, it seems. But not to worry, it's going to start simplifying right now. Both the top and the bottom can be written as 2 separate fractions. You're going to see stuff start to cancel when we do this. So let's begin. So I'm going to write this first fraction as sine u cosine v over cosine u cosine v. I'm going to add to that the other fraction, cosine u sine v over cosine u cosine v. Then you can see stuff that is going to cancel. Next, on the denominator, we have cosine u cosine v over the same thing, cosine u cosine v, minus, in the last part, we make that its own fraction, sine u sine v over cosine u cosine v. Alright, now, sorry guys, my gimbal seemed to have a freak out moment there. It got too hot. So, back to where we were, we're going to cancel some things in each of these 4 mini fractions. So, in the first fraction, we see that the cosine v's cancel. In the second fraction, we see the cosine u's cancel. Down below, everything cancels, because we've got cosine u cosine v over cosine u cosine v. And in the last fraction, nothing cancels. So now I'm going to erase all this and write what we have left after these cancellations. Alright, here's what we have now. I took out everything that canceled, and you can see that the third fraction, the first one on bottom, everything canceled, so you have 1 left. Okay, so now again, remind yourself of where we started this whole derivation at tangent u plus v. What we have at the top, the sine of u over cosine u, well, using the quotient rule for tangents, the quotient identity rather, well, that's just tangent u. Okay, I can start to see this shaping up. Sine v over cosine v, that will be tangent v. On bottom, we'll have the 1 minus. Now, let's talk about this. If we split this fraction up into two fractions multiplied by each other, you can see that the first fraction is sine u over cosine u. That's tangent u, just like on top. And same with the second fraction, sine v over cosine v. That's tangent v. So you have 1 minus tangent u, tangent v. All right, we have derived the formula for tangent u plus v. Now, the trick that we're going to do to get tangent u minus v is the same trick we did for part 2 for the sine u minus v formula. We will rewrite tangent u minus v, which is what we want to derive, as tangent u plus negative v. These are equivalent, but now we have the plus, so we can reuse our result from the previous step, the previous formula derivation, but we will plug in a negative v instead of a positive v wherever a v exists. So tangent u plus negative v is equal to tangent u plus tangent negative v over 1 minus tangent u tangent negative v. Okay, as before, in the second part and the first part, we need to discuss the odd and even nature of all the trig functions that have a negative angle to evaluate. It's just tangent negative v, both on top and bottom. Well, as it turns out, tangent is odd. And so if I plug in negative v, that is equal to negative tangent of positive v. So I'm going to rewrite tangent u, so tangent negative v is equal to negative tangent v. And on bottom, we have 1 minus tangent u negative tangent v. Okay. So on top we're set, but on bottom I'm going to move that negative out in front so I don't get confused here and think I'm subtracting when I'm actually multiplying. These two negatives will combine to make a positive. So all in all, we'll have that the tangent of u minus v is equal to the tangent of u minus the tangent of v over 1 plus tangent u tangent v. And we have derived that formula as well. So we have both sum and difference formulas for tangent, and we are all finished. Thank you for watching all 3 parts of this sum and difference formulas 3-part series. And this is Falconator signing out.